you're looking at SolidWorks sheet metal feature in 5 minutes. The problem with sheet metal is people often don't know where to start. In this video, we are going to start with a basic flange tab feature. We are going to look at how to set one up, what settings to use, how to turn on and off tabs, how to select materials, and the different settings that we need to make our sheet metal part. I'm going to start off with a new of part document, and I let SolidWorks load. I have 5 minutes on my timer, and let's go. First of all, you can see I have lots of tabs across the top toolbar in a standard part file. A lot of tabs here that I don't particularly want. So if I want to turn on or off tabs, or if you don't see your sheet metal tab, you can right click on any tab. Once you get to the tabs drop down, you can travel down and take off the SolidWorks cam tab. I can click my SolidWorks cam and it turns off. If I want to take off my SolidWorks cam TBM click and it turns it off. So pretty much the ones I want to keep, I leave one. I want to keep my sketch tab. I want to keep my features tab. I always want my evaluate tab, and I want to make sure my sheet metal tab is on. Making a sheet metal feature is slightly different than making a regular feature. In this case, we're going to use the base flange tab feature. I'm going to start off like I'm making any standard feature. I'm using top plane right click normal 2. Now, I don't tend to use shortcut keys, especially when I'm demonstrating, but please use shortcut keys when you know them. There's a list of shortcut keys on the internet. And if I was using this software, normally I would use my shortcut keys, but for the purpose of demonstration, it's often better to show the actual buttons themselves. Right click again. We're going with sketch. Now I'm going to draw a rectangle. I'm going with center rectangle. I'm clicking and I'm dragging out the same as normal, and I'm putting in a smart dimension. On my first dimension, I am saying is 200 millimeters. My side dimension, I would put down as 100 millimeters. So I have a 200 millimeters by 100 millimeters rectangle. No difference there. Make sure to use the plane required and all the regular modeling theory. Now I am starting off with my sheet metal. I take my sketch and I go to the sheet metal tab and click the base flange feature. The preview activates and shows my material volume underneath the sketch. On the properties tree, you will see the sheet metal parameters. I can use preloaded material sheet metal parameters, or I can use sheet metal gauges either. But for the purpose of this demonstration, I'm just going to use my own custom sheet metal parameters. I'm going to input my parameters myself. I'm setting my from as plane. Of course, we can use surface face or plane vertex or offset. Very same as an extrude, but under my parameters, instead of a 10 millimeter, I'm going to use 5 millimeter. I can reverse my direction to keep my sketch on the bottom or the top, and I can also use my symmetric, keeping my material in between. So I'm going to take that off, leave it at 5 mil, and I am just going to reverse my direction. Now I have settings for K factor and bend allowance. There's a lot of different settings. K factor and bend allowances are used when bending material rather than just cutting flat plate like this example. So I'm going to leave my K factor at 0.5. And we can explore K factor in another tutorial at a later stage. We will also explore auto relief at a later stage. I'm just going to leave that as rectangle for now. I want to click. You can see I now have a piece of material that is 200 by 100 by 5 millimeters. The next thing is I go to evaluate and I click my mass properties. I want to weigh my piece of material. My piece of material says it's 100 grams. That's fair enough, but my material has no specification. The feature tree tells me the material isn't specified. I need to specify my material to get the correct weight of the component. If I right click on the material, I have my favorites list, which for me has AIS I1020, plain carbon, etc. But if I go to edit material, my list comes up and I have many more that I can choose from. I'm going to go with my 304 stainless steel. I click on the stainless steel. We can see that a mass density of 800 kilograms per meter shows. Compare that density with, say, AISI 1020, which has a mass density of 7,900 kilograms per meter. We can compare different materials by their mass density. Why is mass density important? Because we want to match our density with the material that we're going to use. So for the likes of 304, I want the 304 density. I know my overall weight for my final product is correct. I can also add in custom materials to this list if I wanted. So I'm going to leave it at 304 stainless steel, and I'm going to click apply. I'm going to click closed. And now you can see our material turns to 304. So this is representative of a rectangular piece of 304 stainless steel material that is 200 by 100 by 5 millimeters. And if we want to find a weight, we can click our mass properties and you can see it's 800 grams. We also have an equation here. If you use equations, you know that you can change that material thickness from 5 millimeters to another thickness, and it will link and update as required. We can easily do it by right-clicking Manage Equations, and on our 5 millimeter thickness, we can put in a different variable or a different value. Click OK. We can save the sheet metal part file using the standard save method. That is how you would set up a sheet metal part using the base flange tab feature. If you found this video helpful, please like and subscribe and follow for more 5-minute feature videos. I will also be uploading some practice exercises for these videos, and I would love to hear any comments till the next one.